Good
Salam alaikum
afternoon.
wa rahmatullah. Good afternoon. Our approach, there are some uh, general methods that we can use them for designing algorithms. We are going to talk about uh, these general methods. In this course, we um, study uh, three methods uh, that we write the names here, three methods. The first general method is divide and conquer method. The second method is dynamic programming. And the third method is greedy method. First, we talk about divide and conquer method. What is the divide and conquer method? Divide and conquer. In this method, when we are going to solve a problem, in the first step, we divide the problem into some smaller problem. So we have three steps in this method. This method has three steps. Okay, sorry, steps. Uh, what's these steps? The first step is dividing the problem into a smaller sub problems. Dividing the given problem into some smaller sub problems. For example, suppose you are going to sort a given array. You are given an array of numbers, and you are going to sort the numbers that are in this array. If you are going to use divide and conquer method for solving the sorting problem, in the first step, we divide the input array into some smaller sub array. Okay. Uh, and try to sort uh, uh, that sub arrays first. So the problem is divided into some smaller problem. In the second step, we solve each of these smaller subproblems separately and recursively. Recursively, the sub problems are solved. We solve each of the smaller subproblems separately and recursively. In the third step, we combine, we combine the solutions of the subproblem to make the solution of the original problem. Okay, so the third step is combining the solutions of the subproblems to make the solution of the original problem. Okay, so we have three steps. The first step is dividing the problem into some smaller subproblems. The second step is solving each subproblem separately and recursively. The third step is merging the solutions of the subproblems and make a solution for the original problem. Now, let's consider an example. Suppose we are going to solve sorting problem, or a simpler example. For example, you are going to find the maximum of an array. Example 1. Find the minimum of a given array of numbers. We have array A of n numbers. Okay. One, two, three, four, to n. You have n numbers in an array. You are going to sort the array. If you are going to solve this problem, you are going to find the minimum of this array. If you are going to solve this problem by divide and conquer approach, we should at first divide the problem into some smaller problems. The original problem is that we have an array of n numbers, and we are going to find the minimum number among these n numbers. The first step, we should divide the problem into a smaller subproblems. The first step. Okay, in the first step, we should divide the problem into a smaller one. How we can divide the problem into a smaller one? One choice is divide the array into two equal size parts. I mean, we can divide array A into two sub-array from index 1 to index n divided by 2, and then from index n divided by 2 plus 1 to n. So we have two parts, part 1, part 2. The part 1 is from index 1 to index n divided by 2, and the part 2 is from n divided by 2 plus 1 to index n. So in the first step, we just divide the input array into two equal size sub-arrays. This is not the only choice. We can divide the input array into, for example, 3 part, 4 part. Okay, there is not a fixed decision. There is not a fixed choice. We have many choices. We can select which one is better. Here, suppose that we divide the input array into two equal size sub-arrays. Okay, this is the first step of the approach. The second step, what was the second step? In the second step, we should solve each problem separately. I mean that for part 1, we should solve the problem. This means that we should find the minimum of the part 1. Then we should solve the sub-problem 2, the part 2, that we should find the minimum of the part 2. So we recursively solve the problem for these two parts. The second step. Solving the problem recursively for each sub-problem. This means that if we design an algorithm for this problem, in this step we should call that algorithm recursively to solve each sub-problems. Suppose the name of our algorithm is minimum. Okay, we call our algorithm here minimum func. For example, minimum func. Suppose this is the name of our algorithm. We are going to design an algorithm which is named minimum func that finds the minimum of an array. In the second step, we should solve each sub-problem recursively. So we can call our function, which is minimum func, for each part, for each sub-problem. So in this step, we call minimum func for the first part, which is defined by the name of array, the first index, and the last index of the first part. Then we call again the function recursively for array A, and the first index and the last index of the second part. The first index of the second part is n divided by 2, and the last index is n. So if we do these function calls, uh, the problem is solved for the subproblems. The first call solves the problem for the first subproblem, and the second call, the second function call, solves the problem for the second subproblem. Okay. Suppose we store the answer, the solution of the first subproblem in variable m1, and the solution of the second problem in variable m2. So variable m1 is the minimum of the first part. Variable m2 is the minimum of the second part. Okay. Now in the third step, we are going to find the minimum of the total array of array A in total. How we can find the minimum of the total array using the minimum of the first part and the second part. To do that, it's enough to compare m1 and m2, any of them which is minimum is the minimum of the total array, the minimum of array A in total. So we in the third step, in the third step, we should combine the solutions of the subproblems and find the solution of the original problem. Here we can compare the solution of the first subproblem and the solution of the second subproblem, and any of them which is minimum will be the solution of the total problem. So we get we take the mean function between m1 and m2, and this is the solution of our original problem. Okay. So if we put all of these things that we said all together, we get the pseudocode of our algorithm. We named our algorithm minimum function. So the name is minimum function. It gets array A, first index, for example, I, and the last index j. So I is the first index, j is the last index. Okay. The first step is dividing the problem into a smaller problem. How we can do this? We can compute the middle index. So we set a variable, for example, q to I plus j divided by 2. and then we get its floor. This is the middle index of the array. Okay. For the first step of the method, we just need to compute the middle index. Then we should do the second step of the approach, which is calling recursively the algorithm for the subproblems. So we do this here. We call minimum function, minimum func for the first part, which is from index I to index Q. Q is the middle index which we computed in the first step. Then we call the OR function for the second part, A, Q plus 1, and J. Line 2 and 3 is the step 2. Line 1 is step 1 of the approach. Then in line 4, we combine the solutions of the first part and the second part and find the solution of the original problem. Here it's enough that we return the minimum of M1 and M2. This is the step 3. The step 3 of the approach. So here we design an algorithm that finds the minimum of an array using divide and conquer approach. In the first step of the approach, we divide the problem. That here we just compute the middle index. In the second step of the approach, we call OR algorithm for each subproblem recursively. So we call minimum func for part 1 and the minimum func for part 2. And the third step, we should compute the solution of the original problem using the solution of the subproblems. Here, it is enough that we take minimum between M1 and M2 and return it as the solution of the original problem. Okay. Any question? This example shows how we design an algorithm for a problem. For example, here, the problem of finding a minimum of n numbers. This example shows how we can use this method for designing algorithms for the problems. I will explain again, but before that, I should mention a note. Because divide and conquer approach in this second step, in step 2, recursively call itself. So we should add we should add a stop condition to the algorithm, uh, because the algorithm calls itself recursively. Then that call will call itself recursively, and so on. Uh, this these recursive calls should be stopped at some point. Otherwise, we fall. So,
Please go ahead. Say something good. Sorry دكتور السلام عليكم. دكتور sorry can you hear me?
excuse me. Uh, okay. Um, I told that we need a stop condition. Otherwise, we fall into an infinite recursive calls, and the algorithm will and the algorithm never uh, uh, never finishes if we do not have a stop condition. Okay, so we add a stop condition to our algorithm. At first, we have an array with the first index I and the last index j. Then it is divided into two smaller parts, and recursively that part is also divided into more smaller, into a smaller, and so on. So if we continue and if we go through these recursive calls, the subproblems um, become smaller and smaller until we reach to a subproblem that has only one number. I mean, in that subproblem, the first index and the last index will be equal. Okay, so if we reach to that smallest subproblem, we do not continue recursive calls. So we add another line to the algorithm, which is the stop condition. I write it in red. If I is less than or equal to j, then return a I. This means that if we have only one number in our array, the solution is trivial, and that number is the minimum one, and we do not need to do anything more. So, and we do not have recursive calls. So if we reach to this point that the first index and the last index become equal, we stop the algorithm. We return the only number in the array as the solution and do not continue more. Okay, so the stop condition is if I is less than or equal to j, then return. Okay, now I explain again. In the divide and conquer approach, we have 3 steps for any problem. Suppose we are going to solve any problem. Given any problem, we can design an algorithm for solving that problem. If you are going to design the algorithm by divide and conquer approach, then we have 3 steps in our approach. So our algorithm will have 3 steps. In the first step, the algorithm give the input problem and divides it into some smaller subproblems. Okay. We do not consider the whole problem altogether. We divide it. We divide the problem into some smaller subproblem. The idea behind this decision is that smaller subproblems can be solved easier than bigger problem. So to make solving the problem easier, we divide it into a smaller subproblem. So the first step is dividing the given problem into a smaller subproblems. The second step of the approach is solving each subproblem independently and recursively. Each subproblem is solved independently from the other subproblem. This is done by calling our algorithm recursively for each subproblem. The third step is combining the solutions of the subproblems and making the solution of the original problem. We have an original problem which is divided into some smaller subproblems. Each subproblem is solved, then the solutions of the subproblems are combined, and we try to make the solution of the original one. We do this approach for this problem, the problem of finding the minimum of a given array of n numbers. For example, suppose you have an array of n numbers and we are going to find the minimum. If you are going to design an algorithm for this problem using divide and conquer approach, we should at the first step we should divide the problem into smaller subproblems. One choice here is that dividing the problem into 2 equal size subproblems. So we divide the array from the middle, and this divides the array into 2 sub-arrays of the equal size. The size of each part is n divided by 2. The first part, the indices from the indices of the first array is from 1 to n divided by 2, and the second part, the second subproblem, is the index starts from n divided by 2 plus 1 to n. Okay, so at this step we divided the problem into 2 subproblems. We have here 2 subproblems. In the second step, we call our algorithm. Suppose the name of our algorithm is minimum func. May we may put any name for algorithm. We named our algorithm minimum func. Okay, the name is set by me. So we call our algorithm, I mean minimum func, for the first part to find its minimum, and then call the function recursively for the second part to find its minimum. The minimum of first part, suppose the minimum of first part is stored in variable m1, and the minimum of the second part is stored in variable m2. Okay, so we have function minimum func. It's a name. We call here recursively the function for the first part, then recursively for the second part, and store the solutions into variable m1 and m2. So m1 is the minimum of the first part, m2 is the minimum of the second part. So in the third step, we should find the minimum of the total array. What's the minimum of the total array? How we can compute it from m1 and m2? It's enough to compare m1 and m2, any of them which is smaller, any of them which is minimum between these two values is the minimum of, or it is the minimum of the total array, is the minimum of the original array. So we compute minimum of m1 and m2. And this is the third step of our approach. If we put all of these things together, we get this code. The name of our algorithm is minimum func. The input is array A. The first index is I. The last index is J. The first step of our algorithm is dividing the array into two parts. So we compute the middle index. The middle index it can be obtained by adding first index and the last index, I mean I plus j, then dividing it by 2. I plus j divided by 2 may be may not be integer. So we take its floor to make it integer. So the first part will be from I to q, and the second part is from q plus 1 to j. Okay, if I draw the picture from I to q and from q plus 1 to j. So the second step, in the second step, we call recursively our function for the first part and recursively for the second part. We store the answer of the first part in M1 and the answer of the second part in M2, and then in the third step we compute the minimum of M1 and M2 and return the minimum of these two values as the total solution, as the minimum of the input array, of the minimum of the original array. Then we put a stop condition because our algorithm is recursively. At first, we have an array of n numbers. Then it is divided into two parts. Each part has n divided by 2 numbers. then each part is solved recursively. So that part is also divided into two parts. So we have uh, array we have arrays of n divided by 4. Let me draw. At first we divide an array of n numbers into two parts. Each part has n divided by 2 arrays. Then recursively this array is divided
شلون
more
الصحة ابوي؟ الله يعزك يبارك فيك.
from index 1 to index n divided by 4, and from index n divided by 4 plus 1
شوف
to
عاد
end of.
شفت لي التوصيل شلون
And the
بالضبط
second part is also divided into two smaller parts.
ايه.
Uh, and this division
ان شاء الله.
continues.
يعني انت هسه شفتهن ايش قد صارن الحساب مالتهن؟ ماشي.
Finally, we will reach to
الله جزاك الله خير.
problems that has only one number.
يعني اذا الله يسر وراد اليوم تطلع غير تروح للش اسمه يعني باكر او عقبه.
So it is not needed to divide the array more. This is the stop condition. Okay. So in the first line of the algorithm, we
ان شاء الله.
write
يعني بس اريد
the stop
اعرف هاي
condition.
الشريف ايش قد ياخذ
The stop
تقريبا
condition is
اذا انا
here
يعني هاي
that we have
مسوس.
only one number in the array, and when the first index and the last index
هاي
becomes equal.
42 وياه هي الصغار لو الكبار؟
So
ابو
I
ابو
put the stop condition in the first line of the algorithm. If I is less than or equal to j,
الشريف
then
على
we
8000 صح؟
return the only number of the array as the solution, and we do not continue,
يعني قصدي 100
and we do
جابها
not
10.
uh, do recursive calls anymore.
اي يعني على مود
Okay,
يعني لان اذا
any
يتعرض
question?
ال10 ويصير اكثر راح يصير مثل اسعار بغداد. اي 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 يعني هي 8 ان شاء الله نقول. اي اي ان شاء الله.
Okay. Uh, your friend asks me explain
يسر ان شاء الله الله يسر.
page 40 of the book. Let me open the book. Uh, okay.
ها لا عوفه لا عاد عوفه. ايه. ويعني اريد يعني عندكم قناه على التليجرام او شيء اقدر اشوف باقي البضاعه على مود اوصي شغلات بعد اكثر. يعني على الواع على مود ويا الطلبيه تطلع.
Let me share my screen.
لا انا فهمت قصدي. لا مو تصور لي يعني انت عندك صفحه على التليجرام او بالفيسبوك اقدر افوت اشوف. ماكو ماكو. قديمه. إيه. خير ان شاء الله. بس اريد الاخطبوط. الاخطبوط هذا ابو 1750 اريد من عنده 4 درزن. اي كتبت اي. واريد
You
يعني
see,
هذا اريد ازيده بعد فراح اكتب لك هسه.
Yes,
الاخطبوط
doctor,
اريد
yes.
ازيده
We
بعد.
are see.
اسوي 6 درزن.
okay,
اي
the page uh, number 40.
سويها 6 درزن. ايه ايه 6.
Okay, this is the page number 40. Okay. No,
الاشكال مال هاي الفراوله التنسيل
you ask me that explain this page.
عرفتها صح؟
Uh,
اللي سعرها اكو كبيره اكو ام 3 الارنب.
I explain this page in the following because it's about the merge sort that I am going to talk about it in the following. Okay, so please um,
كل وحده درزن اريد.
okay, I can explain the second example on this one. The second example is that we are going to sort a given array. Okay, we are given an array of some numbers. For example, here we have 8 numbers in an array. The first number is 12, then 3, 7, 9, 14, 6, 11, and 2. You are going to sort. So the problem is sorting. We are going to sort. Okay. And we are going to design an algorithm for sorting using divide and conquer approach. Okay. The first step is dividing the problem into some smaller subproblems. Again, here we divide the problem into 2 equal size subproblems. So if we have 8 numbers in the array, then we divide it into 2 parts. The first part has 4 numbers, and the second part again 4 numbers. The first part is from index 1 to 4, and the second part from index 5 to 8. Okay. Let me explain the algorithm at first, then we are going to this picture and I am going to explain the example. Okay, so please let me back to our slides. The example 2. So example 2, sorting an array. We have an array of n numbers, and we are going to sort the numbers in an increasing order. The first step of the approach is dividing the problem into some smaller subproblems. Here again, we divide the problem into 2 equal size subproblems. The first subproblem has n divided by 2 numbers from index 1 to index n divided by 2. The second part from index n divided by 2 plus 1 to index n. Okay. This is the first part and the second part. Okay, this is the first step. So in the first step, again we compute an index, which is the middle index. Okay, if I here is 1 and j here is n. This is the first step. Then in the second step, we call our algorithm for each of the subproblems.
وياهن
The second step.
ذاك 2000 ونص صح.
Uh,
اي
let we call our algorithm
نفس
by merge sort. I named it merge sort. Suppose the name of our algorithm is merge sort. So we call our algorithm recursively for the first and the second part. For array A from index I
ان
to
شاء الله. بس
index
اهم شيء
Q.
شغلات حلوه يعني تمشي
Then recursively we call
جزاك الله
the algorithm for index Q plus 1
قائمه ان شاء الله.
to index J. This is the second step of our algorithm. Uh, what about the last step,
اي
the third step?
ماستر على الماستر ان شاء الله. شو وقت ما تسوي
Uh,
لي على مود تدز لي
in this
الماستر
step,
الواقعي
we should
راح ارسل
combine
لك اياه
the solution
ان شاء
in
الله.
this
ان شاء الله جزاك الله.
step. We combine the solution. We combine the solutions of the sub problems. Uh, in the second step, we recursively called merge sort for the first part and merge sort for the second part. So after the step 2, after the second step, the first part is sorted and the second part is also sorted. For example, we may have something like this. Uh, in this example, part 1 is sorted, part 2 is also sorted, but if we see the total array, it is not sorted. While the first part is sorted and the second part is sorted, the total array is not sorted. So in the third step, we should combine the solutions of the first step and the second step and compute the total solution. I mean, the first part is sorted, the second part is sorted, but the total array is not sorted. We should rearrange the numbers in the array and make
منو محمد
the whole array sorted.
علي جزء مو
The total array should be sorted. So in the third step, we should do this. In the third step, we should combine the solutions of the subproblems and make a solution for the total problem. But how we can combine these two parts? We put a name for the algorithm that combine the two parts. We name it merge. Merge is an algorithm that we should present to combine the two parts, the two sorted parts, and its output is uh, is sorting of the total array. A sorted total array is its input, is output. So merge gives the two parts and combine them. So we get as input to merge algorithm array A, first index, middle index, and the last index. And this algorithm should combine the two parts. But how we can combine the two parts? It needs some explanation. Please let me come back, go back to this
Doctor,
slide.
how we can merge? Doctor, can we ask
Okay,
a
I
question?
am going to explain. Yes, I'm going to explain.
How?
Suppose the first part is sorted and have the numbers 5, 10, 15, and 25. The second part is also sorted 1, 6, 20, and 3. How we can combine these two parts? To combine these two parts, we let me give these examples in the next slide. Let me go to the next slides and describe how we can merge. I write again the array, which its two parts are sorted. 1, 2, 3, 4, 5, 6, 7, 8. We have 5, 10, 15, 25, 1, 6, 23. Okay, to combine, we use two auxiliary arrays, array L and array R. We copy the content of the first part to array L, and we copy the content of the second part into array R. So so we have in array L 5, 10, 15, 25, and we put infinity as the last number in L. Then we copy the content of the second part in array R, 1, 6, 20, 30, and again we put infinity as the last number in R. We define index I and index j index I is 1 at first, index j is 1 at first. Index I is used for indexing into L, and index j is used for indexing into R. Then we are going to sort array A in total, okay? One, two, three, 4, 5, 6, 7, 8. We use another index, index k, for array A, which is initialized to 1. The minimum number of array L is in the first room. So 5 in array L is the minimum of array L, is the minimum number of array L. The minimum number of array R is in the first room, which is 1. Okay. If we compare the minimum of L and the minimum of R and find the minimum of these two values, that will be the minimum of the total array, okay? Because 5 is the minimum of L and 1 is the minimum of R, the minimum of these two values is the minimum of the total array, is the minimum of array of the original array, okay? So we compare these two values. Any of them which is minimum is copied in the original array A. So 1 is copied to the first room of array A, and because value 1 is copied from array R, the index of array R is increased. So j is increased by 1 and no j is 2. And also the index of array A is increased. Then we again compare the room of L of index I and the room in array R of index j. So at this step we compare 5 and 6. In the previous step we compared 5 and 1. 1 is minimum. 1 is copied to the array and the index of it is increased. Then we compare 5 and 6. Any of them that is minimum is copied to the array A and its index is increased. Here between 5 and 6, 5 is minimum, so 5 is copied to array and its index is increased by 1. So I is increased by 1, I is now 2. Then we compare also the index k is increased 1. Then we compare 10 and 6. 10 and 6. 6 is minimum, so 6 is copied and index k is increased. And also index j is increased because 6 is minimum and 6 is copied to A and its index is increased. Then we compare 10 and 20. Any of them that is minimum is copied to array and its index is increased. So 10 is copied to array A and its index is increased. Then we compare 15 and 20. Any of them that is minimum is copied to array A. Here 15 is minimum, so
لو انت
15
خليتهن يعني اذا ما
is
خالفت
copied to array. The index of k is increased. The index of I is also
لا
increased.
3000 اريده بس السوفتات
Okay.
الكبيره اقدر اقلل من عندهن اسوي لها
Then
30 سوفت
we
أسوي
compare
30 سوفت
the then we compare
ايه
the room of L whose index is I and the room of R whose index is
السوفتات
J.
الكبير
Here, so I mean here we compare 25 and 20.
اكو اشكال انا راح اقول لك
Any of them which is minimum is copied. Here 20 is minimum, so 20 is copied to A and index of A is increased, and also index
شغلات انا رايدهن
of J is increased because the index of the minimum is increased. 20 was minimum, so its index is increased. Now we compare 25 and 30. 25 is minimum, so 25 is
يعني ما
copied,
قصدي ما اقدر اقسم الكميه
its index is increased, and the index of I is also increased. Now we compare infinity and 30.
توكل على الله
30 is minimum, so 30 is copied,
التحويل
index k is increased,
التحويل
and index j is also increased. At last, index I is the index of the infinity in L, and index j is the index of infinity in R, and all of the elements of L and R are copied into A. Because in each step we copy the minimum one between the elements of L and R, so the numbers and the elements of L and R are copied into A from minimum to maximum, and uh, they are in a sorted order. Here we have 1, 5, 6, 10, 15, 20, 25, and 13, which is the sorted order of the original number. And in this manner, two parts are merged, two parts are combined. By this method, we combine the part 1 which is sorted and part 2 which is sorted, and we get an array that is sorted in total. Okay, this is the approach that